easy to understood abhi. What is kinetic energy? What is the energy theorem? Kinetic energy theorem. So what is our first example, Abhi? Tell me.
A block is pushed up a frictionless incline. The work done by the friction force is equals to the change in kinetic energy of the block. Example 2. The car accelerates from rest. The work done by the engine is equals to change in kinetic energy of the engine.
Yeah, means every kinetic energy. So any body experienced as a kinetic energy, that kinetic energy it is equal to work, Abhi. That kinetic energy it is equal to work. So that is states that only work energy theorem, Abhi. Clear? Huh? Work energy theorem states that only kinetic energy it is equal to the kinetic energy it is equal to the work, Abhi. Clear? Everybody. So having kinetic energy anko that is equal to work. That is equal to work, Abhi. Already we are proving it, Abhi. Already we are proving. So that every work it is equal to kinetic energy. So that is only states that the kinetic energy theorem, Abhi. Clear?
Okay.
Yeah, so yeah, second one is also like body is moving from rest. So body is moving from rest to somewhere, Abhi. So body is moving from rest to somewhere means it is in motion. Engine it is in motion. So that engine is experienced a work is a kinetic energy of work. So that engine work it is equal to kinetic energy of work. Then we said that is also experienced as a work energy theorem. Energy is na- never created or not destroyed, but energy is converting from one form to another form. Sorry, energy is never destroyed, Abhi, but never creating. So we are not creating the energy, but we are not destroy the energy, but energy is converting from one form to another. So that is the law of energy, Abhi, law of conservation of energy. Okay, write down one concept, Abhi. Write down one example. A block of mass, a block of mass A block of mass m, 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 moving with in moving with initial speed, moving with initial speed v naught, 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 v naught, v naught, towards a stationary spring, 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 towards a stationary spring of stiffness K, stiffness K, stiffness K, attached to the wall, attached to
Stiffness
the stiffness
or
K,
stiffness?
yeah, stiffness K,
Stiffness scale.
K attached to the wall, 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 find maximum compression, find maximum compression, find maximum compression in spring, find maximum compression in spring, find maximum compression in spring, Abhi. Yeah, what is the given things in problem, Abhi?
Uh, Mass equals to m.
Okay, mass and
Initial speed
initial
v naught.
speed.
U equals to v naught.
Yeah, initial speed is given V naught and and
Towards a stationary spring.
yeah, towards a
Or
stationary.
or
Spring stiffness is also given, that is K. Yeah, one side of the spring where is attached, Abhi?
uh, it's attached to the wall, sir.
Yeah, it is attached to the wall. So I'll draw the diagram, Abhi. So this is the wall. This is the wall. This is the wall. Yeah, this is the wall. Yeah, your spring is like this, Abhi. This is your spring. This is your spring. Spring one end is connected to the wall. One end is connected to the wall. Other end is leaving left them. Other end is left them. So this is the spring stiffness is a K. Spring stiffness is K. Now somewhere mass m of black is there. Somewhere mass m of the black is there. Somewhere like for example here mass of m black is there. So this block is so moving on with the initial speed is V naught. V naught. So this block is hitting on this spring. So this block is moving on like this. So it is hitting. Then your spring is compressing Abhi. Your spring is compressing up to here Abhi. Your spring is originally here. Originally is it is here Abhi. Then after it is hitting, then your spring is compressing like this Abhi. Then your spring is compressing up to here Abhi.
Spring attachment.
Yeah, your
Okay.
one end is attached Abhi, other end is not attached Abhi. It is left. Then it is hitting Abhi. Then it is hitting. Your spring is compressing or not Abhi?
Compressor.
Yeah, it is compressed. Up to here it is compressed Abhi. Up to here it is compressed. From here to here, compressed Abhi. Here it is compressed. So here compressed distance is x is given. So we don't know Abhi, that compressed distance we don't know. That I am taking it is x. That we don't know that compressing length distance it is x Abhi. So this is the given data Abhi. This is the given data was given Abhi. Then you want us to calculate the how much of the spring is compressing. సో ఎంత కంప్రెస్ అయింది అంటే మీన్స్ ఏంటంటే ఎక్స్ క్యాలిక్యులేట్ చేయమంటున్నాడు, ఎక్స్ డిస్టెన్స్ ని క్యాలిక్యులేట్ చేయమంటాడు. స్ప్రింగ్ ఎంత కంప్రెస్ అయిందో క్యాలిక్యులేట్ చేయమని. క్లియర్ అవి అర్థమైందా?
Diagram అంతే కానీ సార్.
యా మీన్స్ ఏంటంటే ఇక్కడ ఒక అంటే లైక్ మాస్ ఎం ఉన్న బ్లాక్ ఉంది అవి. ఈ బ్లాక్ కాస్త ఏంటంటే స్ప్రింగ్ ని హిట్ అయింది. హిట్ అవగానే స్ప్రింగ్ కంప్రెస్ అవుతుందా లేదా? ఇలా హిట్ చేయగానే స్ప్రింగ్ ఇక్కడ వరకు వస్తుందా లేదా
అంటే
స్ప్రింగ్
స్ప్రింగ్
అని?
పైన
Yeah, spring one end is attached into the wall అవి. Another end is జస్ట్ వదిలేసాము, దాన్ని దేని కనెక్ట్ చేయలేదు.
ఓకే.
యా ఇక్కడ ఏంటంటే బ్లాక్ వచ్చి ఇక్కడ అంటే హిట్ అయింది. హిట్ అవ్వగానే స్ప్రింగ్ అనేది ఇక్కడ నుంచి ఇక్కడికి వస్తుందా రాదా? కంప్రెస్ అవుతుందా లేదా?
అయిపోయింది సార్.
ఈ కంప్రెస్ అయిన డిస్టెన్స్ ఏదైతే ఉందో ఎంత కంప్రెస్ అవుతుందో క్యాలిక్యులేట్ చేయమంటాం. దట్ నౌ వీఆర్ క్యాలిక్యులేటింగ్ అది. ఓకేనా? సో కాపీ దిస్ అభి. Copy this away. Now we are calculating how much it is compressing a bit.
Okay, sure.
Yeah, copy now. Yeah, okay. So what is the work done by the spring, Abhi?
Work done by the springers.
Hmm, work done.
Uh, half mv square.
Yeah, very good, Abhi.
No, no.
Work done by spring. Work done by spring. Work done by spring force.
Minus k,
Yeah,
kx minus kx.
excellent, Abhi.
K2.
K2 minus half kx square. K x square.
Yes.
Clear. So what is the initial velocity of the block, Abhi? Here, what is the given in initial velocity of the block is how much is given?
And v naught.
Yeah, initial velocity of block is v naught. So what is the final velocity of the block? Tell me.
Final velocity 0.
The final velocity obviously zero. After compressing, so it is maximum compressing, Abhi. So this is maximum compressing from here to here, Abhi. Maximum compressing from here to here, here to here. So then after here, there is no compressing. There is no chance for compressing, Abhi. So obviously here speed is zero. Here block speed is zero. Your block is stopping here, Abhi. Your block is stopped here only. So that's why final velocity obviously it is zero. Clear, Abhi?
Okay, sir.
Final velocity
Yes.
of block is final velocity of block is zero. Block is zero. Final velocity of the block is zero. Now we are calculating, Abhi. X calculate చేస్తాం ఇప్పుడు. X calculate చేయడానికి K spin constant is given. X we don't know. According to work energy theorem. According to work energy theorem. Tell me what is the work energy theorem, Abhi?
Work energy theorem, sir. Half mv square.
Yeah, energy it is equal to kinetic energy. Energy it is equal to half mv square. Very good. Work energy theorem. That is work equal to kinetic energy. Work equal to kinetic energy. Half mv square. Okay, directly I don't write like that. Kinetic energy. So work equal to kinetic energy. So if that kinetic energy it is not constant, Abhi. So it is changes from initial to final. It is changes from initial to final. So that's why I'm writing kinetic energy it is equal to change in kinetic energy. Change in kinetic energy. What is the change in kinetic energy, Abhi?
Delta
Kinetic
K,
energy.
sir.
Yeah. Kinetic energy for the final minus kinetic energy for the
M
initial.
by 2 of M by
What
2.
is the yeah, what is the final kinetic energy of m of m? What is the final velocity
V final
of m? V final square
whole
minus
square
of m of m
half m V
of
n
m
square.
V initial square. So this is your work. So what is your work, Abhi, here? Here your work is spring or not, Abhi? Spring work
Yes,
है
sir.
दादा. Your work is
Yes, sir. Spring, okay.
spring work. So I'm writing in the place of here W spring work, that is minus of kx square. This is I'm writing of m into what is the final velocity, Abhi, for your spring?
0, sir. So total
Zero.
0.
This is zero minus total zero. This is m into so initial velocity is given v naught square. Now this is minus k of k x square.
Minus
It is equal to minus of mv square. So
mv
here
naught square.
mv naught square. So here what are the cancelling terms are there, Abhi? Here which one are cancelled?
Minus 1 by 2 minus 1 by 2.
minus 1 by 2 minus 1 by 2 is cancelled. What is the x, Abhi? X square is, it is equal to m v naught
MV
square
naught
by
square by K.
mv naught square by k. Then your x
X
equal under root of under
MV
root of
naught square by K.
mv naught square by k. So this is your distance. How much distance your spring is compressed, Abhi?
MV naught square by K.
Yeah, under root of mv naught square by k. So this much of distance your spring is compressed, Abhi. So okay, uh, sorry for I forget, Abhi. The concept is here you can write like this, Abhi. So your work is change in kinetic energy, not for the kinetic energy, Abhi. Change in kinetic energy. So where it is kinetic energy only for given values. Always you are taking only change in kinetic energy for not directly taking kinetic energy. Adding, Abhi. Here adding and finally also you are adding change in kinetic energy. So because of kinetic energy, it is existed in between only final and initial velocities. So directly we are taking final velocity. Here directly we are taking final velocity because of initial velocity is always zero. Initial velocity is always zero. So but in these cases, initial velocity is not zero. In these cases, initial velocity is zero now. Yeah, it is stuck in Navi. It is stuck in Navi.